Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, I want us to talk about sine rule. We are in chapter 6 of Pure Mathematics 1, and I want us to understand the sine rule. And the sine rule is explained in example example 5 moving forward on page 110. But because we know the sine rule, especially the sine rule is generally a over sine a is equals to b over sine b, which is c over sine c. That is the sine rule. And the sine rule is, of course, when we are talking about a triangle of this nature, and this is happening to be A, this is B, and this is C. This is side A, this is side B, this is side C. You can see A over sine A, we are talking about that over sine that, C over sine C, and B over sine B. It moves that way. And we are told that the sine rule can be used to work out missing sides or angles in a triangle. And this version of the sine rule is used to find the length of missing sides. And of course, before we can even know how to use it, do we even know how to derive it? So in this video, we want to learn how to derive sine rule. And assuming that we are having a big triangle that looks like that, and this is vertex A, this is vertex B, this is vertex C, and of course it goes without saying this is A, this is B, that is A, and we have a perpendicular height which is H, and this is X, and the whole of this side is C. We can say, of course, using triangle using triangle CXB, because it is right angle there, we can say that the sine of this angle B, the sine of angle B is opposite over hypotenuse H over A. And from there, you can already make the H the subject of the formula and say H is equals to A sine B. Again, using triangle ACX, we can also have that the sine of angle A, which is this angle, is given by opposite over hypotenuse H over B. And from here, you can make still H the subject of the formula and say is B sine A. And from this, you could easily be able to find that A sine B is equals to B sine A. Fine. If you divide both sides by sine B sine A over sine B sine A over sine B sine A, it follows that the sine B here will cancel with that sine B, and the sine A here will cancel with that sine A, and we are left with A over sine A is equals to B over sine B. Having said that, if we can again drop this perpendicular from point B and make H appear there, and let us have 90 degrees there. We could also talk about sine C is equals to this h, now our new h, over hypotenuse, which is a. We could also say sine c is equals to h over a. And using this triangle a, let's call this qb. Also, sine a is equals to opposite, which is h over c. H over c. And using this, you can still make h the subject of the formula. H equals to a sine c, which is also equals to c sine a, because this is just another h. So if you divide by sine a sine c, sine a, sine c, sine a, sine c, then sine c will cancel with sine c. This is sine a, and sine a will cancel with sine a, and you will be left with a over sine a equals to c over sine c. So if you now have this a over sine a, which is equals to b over sine b, and a over sine a, which is also equals to c over sine c. So we can now narrate all of them and have, therefore, we have a over sine a, which is equals to b over sine b, which is equals to c over sine c. And this is what we are now having as the sine rule. And this sine rule is going to be used to solve triangles in different levels. But yes, there we are. We have been able to derive the sine rule. Follow my YouTube channel, Pearson and Excel International Math by Mr. Kamoto. And of course, subscribe and share widely. Thank you.